Hello. In this last section, we're going to finish up with the last step of the process, which is verification of the object code against the high-level requirements. So we're going to do this two ways. We're just because we've already built up both of these test harnesses, so we can easily reuse both of them. But we're going to use both software in the loop testing, which remember is when we generated code from the model, we had the option to compile that code locally and bring that back into Simulink as an S function, and that's software in the loop testing. And then we've also taken an extensive look at what we call processor in the loop testing, or PIL mode, which is where we generated code and then we actually compiled that code and simulated the compiled object code in the Green Hills instruction set simulator. So we're actually going to be able to do both of those in this step. And all of the same ideas and caveats apply to this step. So again, if we're working in a DO178B environment, then ultimately what we want to be doing here is we want to be using the processor in the loop testing mode, and we want to be communicating with Green Hills and have the Green Hills probe and a development board such that we'd be executing these tests on the object code on the target processor. Again, using the actual hardware doesn't translate that well over WebEx, so I'm just going to use the instruction set simulator. But recall again that the process is exactly the same. So if you've watched the last two sections of this series, you saw how we use this capability to test the object code and verify the object code against the model, which we were treating as our low-level requirements. And that was done with test cases based on Simulink design verifiers, automatic test vector generation. Okay, so the test vectors were based on the model. However, if you watched several steps before, we already did our functional testing, our verification of the model against our high-level requirements. So in this step, we created a system test file that executed our requirements-based tests against the Simulink model. So if you remember from that section, our requirements-based tests were expressed here in an Excel spreadsheet. So for each one of the requirements in our requirements document, we had a test case. And each test case was a time history, right, with inputs and expected outputs. And so what we did in this step was we ran these inputs against the model, and we compared the output of the model against these expected outputs in our test document. So what we want to do is exactly the same thing, but this time instead of feeding the inputs into the model, we're going to feed these inputs into the object code. Okay, and this is really where one of the biggest benefits of system test comes in. So recall that when we did this functional testing of the model against the high-level requirements, we built that system test file. Here we can reuse that system test file exactly. So this is where we start to really get the reuse of test cases across all the engineering domains. So instead of having to have a separate instantiation of all of our requirements-based tests in the model environment, in the software environment, even all the way down to the processor environment, now we can have one instance of the test cases. Right? And we can reuse those in all of these environments, against the model, against the code compiled locally, software in the loop, or against the code running on the target processor, that's processor in the loop. So these are the test cases. So all I need to do to actually satisfy this is just open up exactly that same system test file that we created in this step of the process, testing the model against the requirements. So you can see here my test vectors in this spreadsheet. These are the ones that I read in from my requirements-based test document, this Excel spreadsheet. Okay, and in this case, since the only change I had to make is that instead of executing these test cases against the Simulink blocks, we're going to execute them against this software in the loop. So this was that S function that we created when we discussed code generation and software in the loop testing. So we can take a look at this. It's this one here. So this is that S function block that was automatically generated as part of the real-time workshop embedded coder build process. All right. So what I can do is run this, and so what I'm doing now is executing those requirements-based tests from my Excel spreadsheet against the generated code compiled and running locally on my machine. Okay. So this is software in the loop testing. And we can see that there was 4 requirements-based test cases, so 1, 2, 3, 4. So for all 4 of those, we ran the limit check element, again, was comparing the output of the compiled code, this time running locally, to the expected output from our requirements-based test document. And so in each of these cases, you can see that we passed. And so, of course, there's the test report. And so this is the data artifact that we need in order to take credit for this testing, right? So why you would do this is if you wanted to quickly verify that the code implementation of your model was functionally equivalent. This you can do very quickly. You don't have to have a license for your IDE and a development board and all of that. This is a way to just very quickly kind of check to make sure that nothing funny is going on during code generation and all our code generation options are correct the way we want, and that this is giving us exactly the same results as the model. Okay. But if we want to take certification credit for this testing, this isn't sufficient. So you can't, if you want to take certification credit, then we need to be running on the target processor. And so software in the loop testing is insufficient for that. However, it's very easy for us to repeat exactly the same thing with processor in the loop testing. So if you recall, let me close this guy. In the last section, we talked extensively about processor in the loop testing. So we can actually do exactly the same thing with the processor in the loop block, which you can see here. So we created this in the last section. And so what we're going to do now is, instead of executing those same model-based test cases against this pill block, we're just going to use exactly the same system test file from before when we verified the model against the higher level requirements. So this is exactly that same system test file again, and all I had to change here, so here's my Excel spreadsheet of test cases, and this time I'm just calling out to my processor in a loop project. So that's this guy. And you can see that I also have my Green Hills project is still up, it's still running. So this is going to be the actual code that I'm going to be executing, right? And again, in this case, we're executing in the instruction set simulator. All right, so if I want to execute these test cases, I'll just hit run. And again, this will take a little while because processor in the loop, in general, it has quite a bit more overhead than just normal simulation and Simulink, because every time step we're passing data back and forth between Simulink and Green Hills. So it does take a little bit longer to execute. But while that's running, let's take a look at the workflow again and understand exactly what benefit we're going to get out of this. So if we were using the probe and had a development board, and so we were doing this on the target processor, then what we're doing is our functional testing. So our verification of the object code against the high-level requirements. So this is another set of functional testing that we're explicitly required to do by DO178B. But the great thing about this tool chain is, remember, it took us no work to get to this point because we had already created all of the models and test cases and everything else that we need in order to accomplish this step in doing some of these others. So this is, again, where that idea of reuse really pays off. Right? You get this, everything you need in order to accomplish this step, you've already created. We can just reuse the system test file and the pill block directly that we created in order to satisfy these other steps. So if you imagine when you're doing this for real, you may find an issue, a requirement may change, something like that. Anytime something changes, you're going to have to go through this process again. You have to do all the necessary regression testing. So clearly, the more automated each of these steps are and the more reuse we can get, the faster we're going to be able to do all of our regression testing. And so that's really where most of the time, schedule, and cost efficiencies from a model-based design process like this really come from, is that idea of reuse and automation of all of these steps. The other thing to recall is, again, since we're using system test, and since the limit check element in system test is one of the 3 tools that are included in the DO qual kit that was released in March, when this system test file is done, if it reports that we have passed all of these tests, because this limit check element is qualified as a verification tool, we don't have to check the output of that tool by hand. So not only can we automate the execution of these, but when we get that report that says we passed, it says that our object code is doing exactly what the requirements-based test said they should, that's sufficient. We don't need to do any additional labor or work in order to achieve what we need to for certification. So this is really nice because, again, we can automate the execution of tests and automate the generation of the report that we need to give to the certification authorities to prove that we've done this step. And since the tool is qualified, we don't have to check the output of it by hand. So this, again, is a huge cost and time saver, not having to manually check those outputs, to do a manual review of the outputs of the code against the requirements-based tests, and not having to manually write that document. So you can see here in the system test file that we passed. All right, so again, here's the test report. It's exactly the same as the other test reports that we've been looking at in all the other webinar sections, but you can see here that we're executing our processor in a loop project. So that was actually calling out to the Green Hills environment. So we're really executing the actual object code. And of course, because we had the plot element, we've copied our plots into this report, and so for each iteration, we can see that the data overlaid. So we were overlaying the output of the object code with the expected outputs from our requirements-based test cases. We can see what the limit check results were and whether we passed or failed each iteration. All right, so this is exactly the data artifact that we would need to give to the certification authorities to prove that we had verified our object code against our high-level requirements. So that's really what this step is all about. This is a really fun one to do because, again, it takes almost no work to actually accomplish this. But real quickly, I'll just summarize kind of everything that we've done in all of these sections. So if we just take a quick look at the workflow again. So what we'll see here, what we've managed to accomplish is so we started at the very first section with just a requirements document, and throughout this series of webinars we've managed to, from that requirements document, create an algorithm. From that algorithm, generate the source code and compile it into the object code and do all the necessary validation and verification activities that we need to do in order to satisfy a certification process like DO178B. And of course, remember that something like DO178B, it really is a software development process certification. So it is about the process more than it's about the object code. The whole goal of that particular certification is that the software is developed in a deterministic and safe way. So it's not a coding certification, it's a process certification. And so this is a process that we've kind of explicitly been working on in order to make sure that we're satisfying the requirements that you need to for that sort of development process. And again, with the introduction of the DO Qual Kit in March of 2009, we've been able to extend the automation capability that we can provide in a process like this. So now, not only do you get the inherent automation capabilities that are built into the MATLAB and Simulink environment, but because of the Qual Kit can qualify the limit check element, parts of the model advisor, and parts of polyspace, we can actually save you quite a bit of time as far as manual documentation and also the manual reviews that you would have to do if you didn't have qualified verification tools. So that's a summary of what we did. Again, if you listen to that summary and you haven't caught the rest of the series of webinars, I would actually urge you to perhaps listen to the introductory section where I go through in a bit more detail where this workflow came from, why we're going through this whole process, and what each of these steps really means. So thank you very much.